Hello and welcome to the demonstration of the MechatronicUML code generator for distributed cyber-physical systems. My name is Marcel from the University of Stuttgart in Germany. With this demonstration, we show how we can improve teaching students the design, implementation and functionality of distributed cyber-physical systems like autonomous driving vehicles or cars by designing the software in the MechatronicUML with the real car in mind and then generating the code for artificial robot cars that can then demonstrate this functionality. For this demonstration, we will use an exemplary application scenario that involves two cars driving behind each other, with one car driving faster, catching up, and then sending a message to the other car for requesting an overtake. The other car should then respond with accepting this request. In the first step, we need to model the application scenario. For that, we use the MechatronicUML tool suite that you can see here. It is an Eclipse-based IDE that allows us to create the MechatronicUML models and execute the code generation. In the model folder here, we already provide a complete MechatronicUML model of the application scenario. This includes models of the software components that you can see here in this diagram. Here we modeled components for the distance sensors, the powertrain, the control unit and the coordinator unit. We added ports to this unit that describe which data they can in and output. These components can be combined into a composite component called the robocar here, and there we connect the ports with each other to show the internal communication channels. The behavior of these components can be expressed as well through another type of models called the real-time state charts. You can see an example here for the drive control component. It expresses this behavior through states that can be changed through transitions, and these transitions describe the circumstances in which this transition is executed. Now we can also model the hardware platform, for which we use Arduino-based robot cars, and you can see here one model that contains information about the hardware resources provided by our Arduinos and their specific capabilities. Now we can start with generating code from these models. First of all, we need to generate an intermediate model called a container model. And we do that by clicking on this robocar.muml file, which contains all the other submodels that I showed previously. And you have to click here on export, choose container model and middleware configuration, and then click through this wizard. And we also want to generate MQTT and I2C middleware configuration code. Choose a folder where you want to get this to. And then we have this model here in this folder. And from this, we can now generate the actual container code and middleware configuration files that we need for deploying the software on the hardware platform. Now for the configuration of the actual source code of the components, we can now here again choose export, but now choose source code. And with that, we generate the actual source code of the components, which is also then created in this folder. Next, we can deploy this code on our Arduino-based robot cars. For that, we use the Arduino IDE and open the Arduino sketch that we generated in this IDE and then upload it to our robot cars. And you can see this upload process here. This microcontroller is now connected, and by the blinking light, you can see that the sketch is uploaded and in the end finished. Now we can test the application scenario with our robot cars. And you can see here our test circuit with the black line the robot cars have to follow. And if we place these cars on the line, they immediately start following the line. And as you can see, the fast car is now catching up to the slow car. And when it reaches it, it will maintain a certain distance from this point on to avoid crashing. Now we also monitored the MQTT server to see if the messages are exchanged correctly. And we could see that the robot cars connect to the message broker after they were turned on. And later on, we observed that the fast car sends an overtaking request after reaching the slow car, and then the slow car responded with a message accepting this overtaking request. And with this, we conclude that the envisioned application scenario was correctly executed with the generated code.